For 4.2, we're going to find the inverse of each one-to-one function. Basically, we're doing 47 through 57. I'm doing 47 through 57 odd. You're going to state the domain of f and f inverse and graph both functions on the same coordinate grid. We also have to verify that you did it right and that they are indeed inverses of each other. So we're going to get started with 47, and we have f of x equals 3x. Pretty simple. The first step, what we're going to do is, I'm going to do it this way. We're going to let f of x equal y. So we're going to write y equals 3x. Then we're going to exchange f with y, because basically inverses, that's what you're doing. You're changing the x and the y. So here we have x equals 3y. Then the next step is to solve for y. So we're basically just dividing both sides by 3, so we get x equals, we get 1/3 x equals y. Basically we just divided both sides by 3 here. I don't want to put that there, but anyway, you know how to do that. That's from Algebra 1. X equals 3y. Alright, so that's the inverse, and that equals f inverse. Okay, now we have to check that we did it right. And to check, we're going to do what we did earlier. We're going to compose f with g and g with f. They have to work for both ways. Sometimes it works one way, not the other. So we're going to check f with g of x. So that's going to be, write down f, and we put g of x inside. Basically, we're not going to do that. Let me change that again. We are going to do that, but we're going to use different notation. We're going to compose f with f inverse, and we're going to compose f inverse with f. Basically, you've done this before, and all we're going to do is write down f first. So f composed with f inverse of x, and it should equal x. So I'm going to put f, and f inverse is 1/3 x. So we have 3 times 1/3 x equals x. And then we're going to do f inverse composed with f of x. And that means we write down f inverse, which is 1/3 x. But instead of x, we're going to write 3x. That equals x. Now all I want you to do, so it did check, we did it right, and it's always going to check if you did it right. And we're going to graph these two. So I'm going to put it on the coordinate grid. And we know it has to reflect over the y equals x, and they want you to draw that. So I'm going to kind of draw it here. It doesn't work that great on this thing, so that's your y equals x. And we're going to graph f of x was 3x, so that's y-intercept is 0, 1, 2, 3 over 1, 1, 2, 3 over 1. So let me try to connect these. Whoops. Why is it doing that? Come back down. Let's try it again. So we're going to try it again. We're going to go up 3 over 1, down 3 over 1. So there it is, something like that. This is f, which equals 3x. And then we're going to do f inverse, which was 1/3 x. 1 over 1, 2, 3. Down 1 over 1, 2, 3. You're just graphing linear equations. So it's something like that. And then you're supposed to draw the y equals x. And let me try to draw that here. So it reflects over the line y equals x. This is y equals x. And this purple is f inverse, which equals 1/3 x. and it works out nice. Okay, so the next one is 49, and we'll go a little faster. 49 is f of x equals 4x plus 2. Now, the first step was we changed the f of x to y. We interchanged the x and the y, so x equals 4y plus 2. And then we solve for y. So we're going to subtract 2 from both sides. And divide both sides by 4, so we get x minus 2 over 4 equals y. Okay, now we're supposed to check, so we're going to check f composed with this is y, which equals f inverse. With f inverse, and compose f inverse with f. So the first one here, I'm just going to write f of f inverse, which was x minus 2 over 4. And so that's 4 times x plus 2. I'm going to write x minus 2 over 4. Here the 4's cancel, so you're going to get x minus 2 plus 2, which equals x. That's a check. And we also have to compose f with f inverse with f. So I'm basically writing down f inverse, which is x minus 2. We're going to do f inverse of f, which is 4x plus 2. And I'll write down x minus 2 over 4, and I dump in this. So that's going to be 4x plus 2. So that yields 4x over 4, which yields x. So it works. By now you should be able to do this part right in here pretty easily. We have to graph it. So when we graph it, we get 4x plus 2. I'm going to graph that first so my screen doesn't mess up. So our y-intercept is 2. We go up 4, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. Connect those two. Be good to use a ruler on this one. This is f, which is 4x plus 2. And then for f inverse, basically I'm rewriting it as f inverse. I'm going to rewrite it as x over 4 minus 1/2. If you come back, I'm just rewriting this is right here. I'm writing this as x over 4 minus 1/2. So it's still linear. The slope is 1/4, and I'm starting at negative 1/2. So I'm starting here. I'll do this in a different color. And from this negative 1/2, I'm going up 1 over 4. And I'm going down 1 over 4. So here are my key points right here. And I'm going to kind of connect them here. There it is. This is f inverse, which was x over 4 minus 1/2. And we're also supposed to include our line y equals x. So this is y equals x. They both reflect over y equals x if you did it right. Alright, this was what? 49. So now we're going to do 51. 51 is, we get more interesting here. F of x equals x cubed minus 1. So the first step we're going to do is change f of x to y. Interchange your x and y. Solve for y. So you do add 1 to both sides. And then cube root both sides. So you cube root both sides. So y equals the cube root of x plus 1. And this is where your knowing your parent functions are going to help, that we did at the beginning of the year. Okay, so here we have, this number is what, 51? So basically, we're going to have to check f composed with f inverse and f inverse composed with f. And I'm going to kind of do shorthand here just to save some time. So I'm going to write cube minus 1. This is your f. F of, we want cube root of x plus 1. So you put the cube root of x plus 1 here. These cancel here, this cube with the cube root, so you have x plus 1 minus 1, which does indeed equal x. And then we have to compose the other way, f inverse composed with f. So basically I'm writing cube root of x plus 1, and I'm putting in f, so it's just x cubed minus 1. I'm going to take care of the inner part first. Basically it means I could erase this parentheses here and here, and I'm just going to get x cubed, and these cancel each other out. The cube root of a cube is 1, so that equals x, so that works. Now we have to graph it. So basically, this was your f inverse, and this was your f here. This is your f. So we need cube root minus 1 and the other one. So here we go. So the first one is x cubed plus 1. Now we already know what x cubed looks like. Something like this, right? So all we're doing is shifting it up by 1. So we're doing the same thing and kind of just graph it here. It doesn't have to be perfect. So there you go, something like that. And then the cube root of x, so this was f. This was x cubed plus 1. And f inverse, we're going to do the cube root. We already know what that is, and that's going to horizontally shift over. Now the cube root, remember, looks like this. Something like that. But this is a horizontal shift. We need f inverse, which is cube root of x minus 1. This is a horizontal shift to the right by 1. So instead of starting at 0, we're starting at 1. And you're kind of going to draw it up to 1 here, and it shoots out here, and go down to 1 here, and it shoots out this way. So basically this one should have been a little more like that as well. There you go. You get the idea. Now I have to draw y equals x here. I'm just going to draw it really quick. So this is y equals x. This one is f inverse, which equals cube root of x minus 1. So if you know your parent functions, this is going to be easy to graph. Okay? So it's something like that. Now, 53, we have x squared plus 4, where they say x has to be bigger than or equal to 0. That's your f. So we're going to change that to y and solve for y. Oh, first we have to switch the x and the y. So x equals y squared plus 4, and then solve for y. And you square root both sides. When you square root both sides, you get plus or minus. But here it said x has to be bigger than 0, so we're just going to take the positive. This is the restrictions we have to place on it. Okay? Now, when you check f composed with F inverse. This was your F inverse. We're going to write down F and dump in F inverse. Goes inside here. This will be square root of x minus 4. These cancel. So you get x minus 4 plus 4. That does equal x. And then we have to also compose F inverse with F. So I'm going to write down F inverse. But everywhere there's an x, I'm going to put parentheses, and I'm going to dump in F, which is x squared plus 4. And we get square root of x squared, which equals x. Alright? Now, basically we're going to have to graph this, y equals x minus 4, and we have to graph x squared plus 4, but x has to be bigger than or equal to 0. So, we already know that x squared, so f is x squared plus 4. We already know that this looks like this, right? To shift up by 4, and if you want to do it perfectly, you can. That's what it looks like. But remember, they said it has to be x, has to be bigger than or equal to 0. Why did they say that? They said that because if you do the inverse of this, and I'll show you what that would look like, it's not a function. You see that? It's not a function. So they restricted it like we did with the sine and cosine, and we're only taking this part. So this is your f, and then f inverse we know is square root of x minus 4. That's a shift to the right by 4, and it's something like that. That's f inverse. You should know what the square root of x looks like. You know, the square root of x usually looks like this. It has to be bigger than or equal to 0. So now when you draw your y equals x, something like that, it should reflect over that. Okay. So this was 53, and I think I'm forgetting to state the domain. So we know for the domain of f inverse is it has to be bigger than or equal to 0, and for inverse the domain here has to be bigger than or equal to 4, and f has to be bigger than or equal to what? 0. We'll talk more about domain and range in class, because basically what you're doing is you're switching the domain and range on your inverses. Okay, the next one is 55. So 55 is f of x equals 4 over x. We already know the domain is x, where x cannot be 0. We change f of x to y, and then solve. We switch f of x to y, then switch the x and the y, and then solve for x. So basically, we get y equals 4 over x. It looks like it's the same thing. Okay? Then I'll let you compose them. And if we graph this, I'm going to show you what it looks like. This is y equals x. Okay, you should already know what 1 over x looks like. It looks like this. And since they're the same, basically what we have, I'll put this as 5, and this is 5. And so basically it looks like this. And this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 5, negative 5. And basically this is what it looks like. Okay? And they're both the same. These are both the same. Okay? And let me see what... let's do, okay, so that's it for that, for this video. We'll talk about switching the domain and range in class more, because this video is already getting a little too long. And this is it for now. We are going to also do 59 through 70 in the next video.